If you ever looked at the half angle formulas and felt confused, don't worry, I've been there too. However, after I learned about this proof, it turns out that there isn't actually anything scary about these formulas. They actually make a lot of sense. Not to mention, the proof greatly aids in memorization. Before we get started, this video is based on the reduction formulas, so if you're not quite sure how we got those formulas, I highly suggest checking out my previous videos. With that, let's get started. So we know that the sine squared theta is going to be equal to 1 minus cosine 2 theta over 2. And this is just a reduction formula that we got from last video. So we can square root both sides to get that sine theta is going to be equal to plus minus square root 1 minus cosine 2 theta over 2. So the critical idea is what happens if theta is exactly half of an angle we know. Angle we, it's an ugly we, angle we know. So to visualize this, if we draw this in an xy plane, so let's say we have an angle alpha that we know. This is angle alpha. And we're just going to say that coincidentally, theta is exactly half of alpha. So could we find what half, or could we find what theta is given alpha? Well, as it turns out, we can, because this is what the half angle formula is really about. So we know that theta is going to be equal to, well, half of alpha. Again, this is just, we're just assuming coincidentally theta is half of an angle that we know. And this can just be rewritten as alpha over 2. So what if theta is equal to some angle alpha that we know over 2? Well, if this statement is true, then we can replace all the thetas in this equation with alpha over 2. So let's do that. So then we're going to get that sine of alpha over 2 is going to be equal to plus minus square root 1 minus cosine 2 times alpha over 2 over 2. Well, if you notice here, the 2 times alpha over 2, well, that's just going to cancel out, and that's just going to turn into alpha. So we can just rewrite this as alpha. So this is pretty much the heart of the half angle formulas. So we know that the sine of alpha over 2 equals to plus minus rad 1 minus cosine alpha over 2. So knowing this, we can move on to the other half angle formulas. Let me just erase some stuff so that I have little more space. So we know that the cosine squared of theta is going to be equal to 1 plus cosine 2 theta over 2. Again, we can just square root both sides to get that cosine, or sorry, I forgot the theta. Cosine theta is going to be equal to plus minus square root 1 plus cosine 2 theta over 2. And just to be clear, the plus minus is here because when we have something like, let's say, x times x, or we're going to get x squared. But negative x times negative x is also going to give us x squared. So when we ourselves square root a side of an equation, well, we just have to make sure that we consider both the positive and negative answers. And just adding on to this, just a little bit of Algebra 2 review. If you have, let's say, the even root of x to some even power, and your result is x to some odd power, well, you just have to make sure that you add absolute values here. But however, we have the even root of x to some even power, and you get x to another even power, well, then you wouldn't need the absolute value. And this is because if x is, it doesn't actually matter what x is. It could be positive or negative. However, but then, so even if it's positive or negative, the even power here is going to make it positive. And this is important because when you're taking an even root, you cannot get a negative number. That is, if you're working with real numbers. So for the most of the time, you're going to be working with real numbers. So that's why there's this rule here. But if you have, but in this case, if you get x to some odd number, well, if x is negative, then x to, or a negative number to an odd exponent is also going to be a negative number, and then you would get a negative number as a result of an even square root. So that can't happen. So that's why you need to put absolute values. So that's just a thing to take note of, and just a little bit of Algebra 2 review. So let's get on with the proof. So we can replace theta with alpha over 2. Again, alpha is an angle that we know. So if we wanted to find the half of alpha, if we wanted to find the cosine of half of alpha, well, then this would just be equal to plus minus square root 1 plus cosine 2 times alpha over 2 over 2. And then the 2 times alpha over 2 are just going to cancel, and we're going to get, or we're just going to get alpha. So cosine of alpha over 2 is going to be equal to plus minus rad 1 plus cosine alpha all over 2. So now let's move on to tangent. We know that tan squared theta is going to be equal to 1 minus cosine 2 theta all over 1 plus cosine 2 theta. So we can just pretty much do the same steps as we have been doing so far. I'm going to square root both sides, so we get that tan theta is going to be equal to plus minus square root 1 minus cosine 2 theta over 1 plus cosine 2 theta. And then we're going to replace all the thetas with alpha over 2. So then we're going to get that tangent of alpha over 2. It's going to be equal to plus minus square root 1 minus cosine theta, or cosine alpha, over 1 plus cosine alpha. And there aren't any alpha over 2's because we have the 2 here. Well, and that's just going to cancel with the 2 in the denominator of alpha over 2. So that's why we just have an alpha. And that is going to be the tangent formula for half angles. So one thing that I want to make note of is that the plus minus signs in all of these equations don't imply, I repeat, do not imply that both answers are correct. What it really says is that, well, it could be positive or negative, but whether it's positive or negative is going to depend on the quadrant that you are in. So where cosine alpha over 2 whatever quadrant alpha over 2 lies in, that's the sign that you're going to want to use. So if alpha over 2 is in first quadrant, then you would use, well, everything is positive here. Alpha over 2 is in the second quadrant, sign is only positive. If alpha over 2 is in the third quadrant, then tangent is going to be positive. And if you are in the fourth quadrant, then cosine is going to be positive. So just keep that in mind. And another thing I wanted to talk about was a simpler method or a simpler formula of the tangent formula. So right now we know that tangent of alpha over 2 is going to be equal to plus minus 1 minus cosine alpha over 1 plus cosine alpha. Well, it turns out we can actually simplify that further. Because what if we multiplied everything by, well, square root? Or what if we multiplied something by its conjugate? So let's say we multiplied everything by the conjugate of 1 plus cosine alpha. Actually, I'm going to split up the terms. So what if we multiplied everything by 1 plus, or the square plus minus square root of 1 plus cosine alpha over plus minus square root 1 plus alpha, or cosine alpha. Well, if we multiply this, if we multiply these things together, we're going to find that this is going to be equal to, well, for one, the radicals are going to cancel out as well as the signs. It's just everything's going to be positive. So, well, sorry, let me iterate that. The radicals, at least in the numerator, are not going to cancel out immediately. However, for the denominator, because they're just the same term, well, we'll see. So this is going to be equal to 2 plus minus square root 1 minus cosine alpha multiplied by 1 plus cosine alpha. Well, actually, I'm pretty sure the signs would cancel out, because if you have, well, if you assume positive and you multiply by positive, well, you're gonna get a positive. And then if you assume negative, multiply by negative, well, you're also gonna get a positive radical in the end. So we're good. So I think the signs are just gonna cancel out, and we're just left with square root of 1 minus cosine alpha, 1 plus cosine alpha, over, again, the signs are going to cancel out, 1 plus cosine alpha squared, because we're multiplying cosine alpha by itself here. Well, the square root and the exponent are going to cancel out, so this is just really going to be equal to, this is really going to be equal to 1 plus cosine alpha. And we can rewrite the numerator as well. So if you recall, a plus b multiplied by a minus b, well, that's going to be equal to a squared minus ab plus ab minus b squared. And so that's just going to simplify into a squared minus b squared, because the ab's, well, you're subtracting ab and then you're adding it back, so that's just going to equal to 0. So if you have a plus b multiplied by a minus b, you're going to get a squared minus b squared. And then we can use this property to help us here. So we're going to get square root a squared, which is 1 squared, minus cosine squared alpha, which is just b squared, all over 1 plus cosine alpha. Now, if you see this, well, hopefully you've thought back to the Pythagorean identities, because we know that sine squared theta is going to be equal to 1 minus cosine squared theta. And this is just an alternate form of writing the Pythagorean identity, which says sine squared theta plus cosine squared theta equals to 1. This is just an alternate writing of it. So actually, all of this is going to be equal to sine squared theta, or square root of sine squared theta, over 1 plus cosine alpha. And the exponent and the radical are just going to cancel out, and then we're just going to get, or not theta, sorry, this is going to be alpha. And we're just going to get sine alpha over 1 plus cosine alpha. So tangent of alpha over 2 is also going to be equal to this. And again, just make sure you are applying the signs. So this could be negative or this could be positive, depending on what quadrant alpha over 2 is in. And you can also do this another way. Instead of multiplying by the conjugate, I'll do this in another color. Instead of multiplying 1 minus cosine alpha over 1 plus cosine alpha, instead of multiplying by the conjugate of the denominator, let's multiply by the conjugate of the numerator. Or I'm sorry. Actually, I mixed things up. So in the first time, we multiply by the conjugate of the numerator, because the conjugate of 1 minus cosine alpha is going to be 1 plus cosine alpha. But what I'm writing here in white, we should multiply by the conjugate of the denominator. So that's just going to be 1 minus cosine alpha. Sorry for mixing those things up. So let's multiply this by plus minus 1 minus cosine alpha over plus minus 1 minus cosine alpha. And again, the signs are just going to cancel out, because positive times positive is going to be positive, negative times negative is also going to be negative. So no matter what sign you choose, you're just going to get a positive radical, or positive numerator and denominator. So this is just going to be equal to 1 minus cosine alpha squared over, actually let me rewrite that, I need a bit more space, over the square root of 1 plus cosine alpha (1 minus cosine alpha). Kind of running out of space here, so I hope you guys can still see. This can be simplified. The square and the radical are going to cancel out, so they're just going to be turned into 1 minus cosine alpha over, and then let's multiply the bottom part out to get 1 a squared minus b squared, so 1 squared minus cosine squared alpha. And if we remember our identities, 1 minus cosine squared alpha is the same as sine squared alpha. So this is the same as 1 minus cosine alpha over square root sine squared alpha. And the square and the radical are going to cancel out to get 1 minus cosine alpha over sine alpha. So this is also another way for to write the tangent half angle formula. So that's pretty much all there is for the half angle formulas. I hope this video was of value to you. If it was, please consider supporting the channel. And or if you like this no BS concise way of teaching, then please also consider supporting the channel. Regardless, thank you so much for your time and attention, and good luck with your studies.